Good day, everyone. My name is Martin Horsch, and I represent UK Research and Innovation. And this is to present the contribution number 533, titled Ontology-based Semantic Interoperability on the Virtual Materials Marketplace. The Virtual Materials Marketplace, abbreviated VIMMP, is a Horizon 2020 project that aims at building a digital platform by that same name, a digital marketplace on which all kinds of services, products, transactions related to the field of materials modeling can be traded. This includes what we call translation, that is bringing an industrial engineering problem to the level of materials modeling and evaluating it there, and then translating it back to obtain an actionable decision, and everything that relates to materials modeling, which we conceive of as occurring at 4 distinct levels, which is the electronic level or quantum mechanics, the atomistic level, mesoscopic modeling, and continuum modeling. And now, for such a digital platform, as is the case for many such platforms, we have a semantic technology approach based on ontologies, on domain ontologies, by which everything that can potentially occur at the VIMMP knowledge base can be formalized. This is what you see visualized here. We have 8 domain ontologies that we develop, and this integrates into approach toward semantic standardization that is advanced by an overarching organization, which is called the EMMC, the European Materials Modeling Council, which has already developed a series of standards, including metadata standards, one of which is a top-level ontology, the European Materials and Modeling Ontology, under which or with which those domain ontologies are aligned, and a standard for describing simulation workflows, which is called MODA, that stands for Model Data, among others. And one of the issues discussed on the poster is how exactly this alignment from the domain ontology level to the foundational level occurs. As is usually the case, the relations of the foundational ontology are comparably abstract, and the relations in domain ontologies are comparably specific, so that a one-to-one alignment is not straightforwardly feasible. For that reason, with a 2-step approach, where first the individuals and the relations are mapped one-to-one to an intermediate level, and then to the actual top level where the structure of the knowledge graph is altered. And then another aspect discussed is the representation of simulation workflows, which in materials modeling easily can become relatively complex. And for this purpose, we have a dedicated domain ontology, the Ontology for Simulation Modeling and Optimization, which is abbreviated OSMO, that is the ontology version of the MODA metadata standard. And we have an associated visualization technique for the simulation workflows, where the visual elements correspond one-to-one to elements from the ontology. And in this way, also materials models and everything else that pertains to modeling simulation workflow can be represented as a knowledge graph, and can also be given a hierarchical representation, for example, in JSON-LD, as it is shown here.